absolute value inequality is the last type of inequality that we're going to work with. And we're going to start with a very simple inequality. We have the absolute value of x is less than 5. And we just got to look at, okay, well, what numbers would satisfy this inequality? The way that we would go about solving this is we can take a shortcut. Kind of like when we solved these before. Let's say we had x equal, or the absolute value of x equals 5. We would set x equal to 5 and x equal to negative 5. And those would be our two solutions. We're going to do a very similar thing here, where now that it's an inequality, we're going to split it up into two cases again. So x is less than 5 and x is greater than negative 5. So we have to flip the sign and use the negative version. And what we end up getting here is this situation down here. X is between negative 5 and positive 5. And that would mean any solution between those two numbers. So negative 5, let's say 0's here and 5's here. Anything in there should satisfy that equation. But you can see if we took like negative 6, which would be over here, and put it in here, the absolute value of negative 6 is positive 6, which is not less than 5. Same as if we were to go above 5 and use positive 6. So anything that's a part of our solution would be in here. So we're going to use this shortcut to help us solve any absolute value equation, such as these two. So still going to set up a case 1, case 2, just like we always have. And case 1 is x plus 4 is less than or equal to 2. And we just solve this. So we've got minus 4. And then we've got x is less than or equal to negative 2. Alright, so we've got that part figured out. And then case 2, we take x plus 4. And blue's not the best choice there, is it? Let's use black. X plus 4 is greater than or equal to negative 2. So we just use the negative version of the number and flip the sign around. And we solve it the same way. Subtract 4, and we've got x is greater than or equal to negative 6. Now we can combine this together into one statement, and it looks, well, we can graph first too. So if we're at negative 2 and negative 6, let's see what we've got here. We've got x is less than or equal to negative 2, but x is greater than or equal to negative 6. We're going to end up getting this situation where we're in between these two values. And if you really want to figure out what's going on there, so this would be an and statement. You could say negative 6 x and negative 2, and write the solution like that, or use an and. But where you're going to figure out if it's an or an and is you can just test a point that's in between those 2 points. So I could have checked maybe negative 4 and checked to see what would happen if I put negative 4 in for x. Well, negative 4 plus 4 is 0, and the absolute value of 0 is 0, and 0 is less than or equal to 2. So I know that since this is part of my solution, I got to bring those points together. Alright, just like we did before, make sure you solve for the absolute value first. So before you do your case 1, case 2. So we want to subtract 5 on both sides for the second one, where we're left with x minus 8 is greater than or equal to 6. And then we can set up our two cases. So case 1, we'll use x minus 8 is greater than or equal to 6. And case 2 will be x minus 8 is less than or equal to negative 6. Solve the same way. So add 8, and we've got x is greater than or equal to 14. And we've also got x is less than or equal to 2. And again, we can graph those 2 points and figure out what kind of statement we have. So it's like a little shortcut. Or you can figure it out right I just put 2 here and 14 over here, I know I've got x is greater than or equal to 14, which is going to go this way, and x is less than or equal to 2. So we can figure it out that way. So this is going to be an OR statement, so I could say that that is my solution. Again, too, you can check a point in between 2 and 14. It shouldn't work for this absolute value. So if we picked 5 and put it in for x, so we got 5 minus 8, which is negative 3, and the absolute value of that is positive 3. So we'd have 3 plus 5, which is 8, but 8 is not greater than or equal to 11. So we are good there, because 5 shouldn't be a part of our solution. So that's what we would do there. I have 2 more examples that I'll give you on the next video, and that'll be it.